When I was a little boy, at the age of 5, I had something in my pocket, keep a lot of folks alive. Now I'm a man.
Section 3.3 is on special angles, and what our goal is in this section is to be able to answer questions like this. Find or evaluate the sine value for 300 degrees. How much is sine of 300 degrees? Well, it doesn't sound hard. Just pick up your calculator, right? No, we're going to learn how to do it without a calculator. Unbelievable. In order to do that, we're going to use some special triangles. The first one's a 45-45 90-degree triangle, and you can probably see that this is your 90 degree here, and this is supposed to be a 45-degree angle here and a 45-degree angle there. Now, if you have a triangle that has two angles that are the same, then it also has two sides that are the same. In other words, it is an isosceles triangle. So the sides that are across from these equal angles will also be equal. So the side that's across from this angle is this one, and the side that's across from this one is that one. So these two sides are equal to each other. It's an isosceles triangle. So what we're going to try to do is we're going to try to figure out what sine 45 is and cos 45. We want to fill in this table down here. And we have a right triangle, so we can use sine and cosine and stuff. But we don't know any of the amounts here, like the side lengths. So you get to pick anything you want. But if, for example, you pick 7 here, what has to go here? 7. We said it's isosceles. But let's not pick 7. What's something easier to pick than 7? Well, why don't we pick 1? That's a really easy number to work with. If you didn't pick 1, but you did pick 7 or 17 or 26,000 or whatever, it'll still work, the work we're going to do right now. It would just simplify down to the same answers. Okay, in order to figure out sine, cos, and tan, we need the hypotenuse. So how are we going to do that? We're going to use Pythagorean theorem. So c squared, that's the hypotenuse, equals this side, 1 squared, plus this side, 1 squared. So c squared equals 1 plus 1, c squared equals 2, so c equals the square root of 2, and just leave it just like that. Don't put it in your calculator and get a decimal. Great, now that we've done that, we can figure out sine, cos, and tan of 45 degrees. Let's start with sine 45. So if I want to know what sine 45 is, I look from either one of these 45-degree angles. It'll be the same, so I'll look from this one. Sine equals opposite over hypotenuse. Opposite is 1, and hypotenuse is root 2. So there you go. Sine 45 equals 1 over root 2. Now, you don't have to, but it's not bad to get into the habit of rationalizing these. So remember how to rationalize denominators? We don't want a square root down here. How do we get rid of the square root? We multiply it by itself. But what we do to the bottom, we also have to do the top. In that way, what we're really multiplying by is 1. Root 2 over root 2 is 1, and whenever you multiply by 1, it doesn't make a difference. So 1 times root 2 doesn't make a difference to the amount. It might make a difference in the way it looks. It is going to look different. 1 times root 2 is root 2, and root 2 times root 2 is 2. There we go. Sine 45 is root 2 over 2. We can put that in. Sine 45 is root 2 over 2. Okay, cosine 45. I won't write it here, I'll just go directly down there. If I look at the 45 and I look at cosine, that's adjacent 1 over hypotenuse, root 2. It's also 1 over root 2, and if we rationalize the denominator, root 2 over 2. Tan. Tan is equal to opposite over adjacent. Opposite, 1, adjacent, 1. So 1 over 1, or just 1. There we go. Alright, now we're moving on to the second special triangle. It's a 30, 60, 90 degree triangle. So this is supposed to be a triangle where all the sides are the same length. In other words, it's an equilateral triangle. If it's equilateral, how much are each of the angles? Well, all the angles are equal, so they have to add up to 180. It's 60 degrees, 60 degrees, and 60 degrees. Great. Now, what do you know about all the sides? They're the same. So how much do you want to name them? Probably what you're writing down already is 1. But believe it or not, we're not going to name them 1 this time. It makes it easier if we name it 2. And you'll see why in just a second. Okay, now we want to do sine, cos, and tan here, but we don't even have a right angle. There's no right angle triangle. So how are we going to do this? We're going to make a right angle triangle. What we're going to do is we're actually going to cut this right down here. It's supposed to be straight. Whoa, that's really, really bad. It's supposed to be a right angle triangle like that. So let me just draw this triangle here. I will draw that triangle over here. Okay, and what I have is a right angle right there. How much is this side here? Well, it's still exactly the same as this, so it's still 2. This angle we know, it's still the same, it's 60 degrees. Okay, there's a couple things we don't know, but we can figure out. How much is this angle? Well, if this is 60 and this is 90, how much does this have to be so they add up to 180? It has to be 30. So there's our 30, 60, 90 triangle. We said that's what we were looking for. How much is this side? Well, the whole way across was 2, and basically what we did when we brought it down here is we cut it in half. The only way we know we cut it in half is because this is isosceles, 2 and 2. If this was 2 and 2.2 here, or 3 or whatever, it wouldn't cut it in half, but it does in this case. So this is 1. That's why we started with 2, 2, 2. So when we cut it in half, it becomes a nice whole number, 1. We still need this side. How are we going to do that? Pythagorean theorem. But be careful, this time you have to subtract. The hypotenuse is 2, so 2 squared, minus the 1 squared equals a squared, I'll call it. 4 minus 1 equals a squared, 3 equals a squared, so a equals the square root of 3. This side right here is the square root of 3. Okay, and then we're going to figure everything out. Let's start with 30 degrees, and let's do tan 30 first this time, because this is when we're going to need to rationalize. So tan 30, I look from 30 degrees, and tan equals opposite, which is 1, over adjacent, which is root 3. 1 over root 3. We got a radical in the denominator, so let's rationalize. Multiply by root 3, multiply by root 3. If you do that, you end up with root 3 on top, and root 3 times root 3 is 3. So tan 30, which goes right here, is root 3 over 3. How about cosine 30? Cosine is adjacent root 3 over hypotenuse, 2. So root 3 over 2. How about sine 30? That's opposite, which is 1, over hypotenuse, which is 2. Do the same for 60. Let's start with sine this time. Sine 60 equals opposite, root 3, over hypotenuse, 2. Cosine 60 equals adjacent, 1, over hypotenuse, 2. And tan 60 equals opposite, root 3, over adjacent, 1. So root 3 over 1, or just root 3. Awesome. But there's one problem. We still have these zeros and 90 here. How are we going to figure those out? We can't draw a triangle that has a 0-degree angle in it, or draw a right triangle that has two 90-degree angles in it. It doesn't make sense. So how are we going to do it? What we're going to do is we're going to think back to last day when we were working with angles in standard position, and I'll just draw a first quadrant angle. And what we said we could do is we could take a point and we could call it P, and if we dropped this down, it would make a right angle, and this was our theta. And if this point has the coordinates x, y, then this amount down here is x, and this amount right here is y, and we called this amount from here to here, remember what we called that? We called it r. And what we came up with is that sine of theta is equal to opposite over hypotenuse, which is y over r, and cos theta is equal to adjacent over hypotenuse, which is x over r, and tan theta is opposite over adjacent, which is y over x. We can use those to figure out these amounts, because let's draw a standard position angle that's 90 degrees. So that would look like this. Initial side here and terminal side there. And we're going to pick a point on there. Let's pick a point we actually know. Like, you can pick any point here. What would be a really easy point to pick? How about one step up, which is 0, 1. That point's 0, 1 there. Great, now we just plug everything in here. Sine theta, or in this case sine 90, I guess, sine 90 equals y over r. The y value is 1. R, how much is r? Remember, r is the distance from the origin to the actual point. So what's the distance from the origin to that point right there? 1. It's one step up. So sine 90 is 1 over 1, or 1. Okay, cos 90. Well, it says here that cos is equal to x over r. Well, x in this case is 0, and r is 1. So it's 0. And tan 90. Tan is equal to y over x. Y is 1, and x is 0. 1 divided by 0. What? You can't divide by 0, remember? So this is undefined. There's no such thing as tan 90. Okay, let's do the same thing again, but this time we'll do a standard position angle that's 0 degrees. So here's the initial side, and here's the terminal side. I'm just drawing it right on top. And we can pick any point we want. What would be a great point to pick? How about one step over? 1, 0. Okay, sine 0 equals, so sine's y over r. The y amount is 0. And how much is r? Remember, it's this distance from here to here. It's 1 again. 0 divided by 1 is 0. So this is 0. Cos 0. Cos is x divided by r. X is 1, r is 1, cosine of 0 is 1. And tan of 0. Tan is y divided by x. Y is 0, x is 1, 0 divided by 1 is 0. Done. So we filled in the whole table. Now, you need to memorize this table. And you need to know it this year, and you need to know it next year, and you need to know it well. So, one way to do it is just to actually memorize all these things. And that's kind of tough. Another way to do it is to draw these triangles every time and do what I did down here. And that takes a lot of time. And it also requires some memorization, doesn't it? So, I'm now going to teach you a trick. I'm going to focus in on sine here. Okay, we're going to do sine first, and we're going to go from 0 up to 90. And rather than explain it, I'm just going to show you. I'm going to write the square root of 0 over 2, and I'm going to write the square root of 1 over 2, and I'm going to write the square root of 2 over 2, the square root of 3 over 2, and the square root of 4 over 2. Do you see that this actually works? I mean, that's a pretty easy pattern. Put everything over 2 and go square root of 0, square root of 1, square root of 2, square root of 3, square root of 2. What's the square root of 0? Square root of 0 is 0. So I just get 0 over 2, which is 0. It worked. What's the square root of 1? Square root of 1 is 1, and it's still over 2. Yep. Square root of 2 you can't do, so you just leave it. There it is. Square root of 3. Yep, can't do anything to that, so you just leave it. Square root of 4 is 2, and 2 divided by 2 is 1, so it worked. There you go, we got the first row. How are you going to get the second row? Well, take a look at the first row and the second row, and hopefully you're going to notice something. Take a look at this 0 and that 0. Take a look at this 1 and that 1. Do you see they're just reversed order? 0, 0, 1 half, 1 half, root 2 over 2 over 2. They're just flipped around. So no problem. Once you got sine going this way, write the same numbers that way, and you got cosine. That leaves us with tan. How are we going to get tan? Okay, there's a very important property about tan, and it is that tan theta is equal to sine theta divided by cos theta. I believe we might have mentioned that last year. So let's try that. If we take the sine value, 0, and divide by the cos value, 1, 0 divided by 1, I'll just write it in here, 0 divided by 1 equals 0. That's true. Let's look at this one. Root 2 over 2 divided by root 2 over 2. We're dividing it by the same thing. Whenever you divide by the same thing, you get 1. So that worked. How about this one? 1 divided by 0. Can't divide by 0. Undefined. That leaves us with these two. A little bit more awkward, but we can do it. 1 half divided by root 3 over 2. Remember how to divide fractions? Keep the first one the same, you multiply, and you flip the second one. And you can do some canceling out here. You get 1 over root 3. 1 over root 3, that's not what we got here. Well, it actually is, because remember, if I look back here, there it is, 1 over root 3. And if you rationalize, you get root 3 over 3. If you leave it in this form, it's actually okay. I'm okay with it. Okay? Okay, the last one here, we would have to divide root 3 over 2. And we're dividing it by 1 half. So again, keep the first one the same. Flip the second one. And again, you can ninja slice. You get root 3 over 1, which is just the same as root 3. So this is the one little hiccup, I suppose, is that when you get this, it's unrationalized, but that's fine. Or you can rationalize it right now and you get that. Alright, I know that seemed like an awful lot, and you're probably, it's a blur, and you're probably screaming, oh no, why are you erasing this? I'm just going to show you it's really not that bad to do this. Okay, so here's how you could fill in this table, because remember, you do need to be able to do this. So here I go. I start with sine, and I go square root of 0 over 2, which is just 0. And then I do the square root of 1 over 2. Square root of 1 is 1, so 1 over 2. The next one's the square root of 2 over 2. Can't do anything, keep it. Square root of 3 over 2. Can't do anything, keep it. Square root of 4 over 2. Well, the square root of 4 is 2, and 2 over 2 is 1. Now I just write them in the opposite order. So 0, 1 half, root 2 over 2, root 3 over 2, and 1. Now I divide. 0 divided by 1 is 0. Go to this one. Root 2 over root 2. root 2 over 2 divided by root 2 over 2. You're just dividing the same thing by itself. So it's 1. 1 divided by 0 you can't do. It's undefined. Okay, this one. 1/2 divided by, but I'm going to multiply and flip. Those cancel out. I get 1 over root 3. Or if you want, root 3 over 3. And this one, root 3 over 2 divided by, but I'm going to multiply and flip. 2 over 1. These cancel. Root 3 over 1. I'm finished. Okay, you need to be able to do that. Okay, now we're ready to evaluate some angles using that table we just filled in. So we're going to evaluate sine 300. The first thing you want to do is you want to make a little sketch of that angle. So it's an angle in standard position. There's the initial side. 300 degrees. Well, there's 90, 180, 270, so it'd be somewhere out here. This is our standard position angle of 300 degrees. But remember, we're not actually going to use that angle. We're going to use the reference angle. We're going to use this angle right in here. So what's the reference angle? The reference angle in the fourth quadrant, the way you get them is you take the whole way around 360, subtract the standard position angle 300, and you get 60 degrees. So this is our reference angle, 60 degrees. Now the other thing you have to think of is in the fourth quadrant, what sign is sine? Like, is sine positive or negative? Sine in quadrant 4 is, so let's write this up here. Remember, angry, Serbs, take, creatine. In quadrant 4, the only one that's positive is cosine. So that means sine is negative. Okay, now all we have to do is we're going to take the sine value of the reference angle, which is 60. Sine 60 degrees equals, well, eventually you're going to memorize them, but we filled in the table, so let's go down and look at it. Sine 60 equals root 3 over 2. So we can now take this bit of information, the negative, and this bit of information to say that sine 300 equals negative root 3 over 2. And I promise you, if you take your calculator and put sine 300 in it, you will get this amount. You can try it if you want. Okay, let's do another one. Exactly the same sort of idea. Tan 210. So we think of where the standard position angle ends up. There's 90, 180, so it'd be down in the third quadrant. This whole amount is 210 degrees, but we're only going to worry about the reference angle right there. The reference angle in the third quadrant, the way you get it, remember this is a little tricky one, you take the standard position angle, 210, and you subtract 180. And if you do that, you'll get 30. So the reference angle is 30 degrees. Okay, in quadrant 3, tan in quadrant 3, is it positive or negative? So again, let's look up here. In quadrant 3, the only one that is positive is tan, and that's the one we're talking about, is tan. So in quadrant 3, that's 3, it is positive. And the last thing we have to do is ask ourselves, what is tan of the reference angle? What is tan 30 degrees? And that's where our table comes into play. We look at the table, and tan 30 is root 3 over 3 or 1 over root 3. But I'll go with root 3 over 3. Root 3 over 3. So now we can say that tan 210 is positive, but I won't even write that, root 3 over 3. There's our answer. Okay, find all the angles between 0 and 360 such that cosine theta equals negative 1/2. So there's some angles, more than one, that have a cosine value of negative 1/2. Do you know how many there's going to be? There should be 2 of them, because there's 2 quadrants where cosine is negative. Where's cosine negative? They're all positive here, so it's not there. Cosine's positive here, so it's not there. But these two, only sine is positive, so cosine's negative, and only tan's positive, so cosine's negative. So the 2 quadrants, I guess I'll just write it here. Cosine is negative in quadrants, what were those quadrants? 2 and 3, right? Okay, next thing we have to ask ourselves, the cosine of what angle it equals 1/2. So don't worry about the negative. We've already dealt with the negative here when we thought of which quadrants it's going to be in. Now we just think of the 1/2. So if you think about it in the table, eventually you'll memorize this, but we'll look it up right now. There's going to be some an angle in the table where cosine of that angle is 1/2. So let's take a look. For which angle is it where you look in the cosine row and you see 1/2? Right there, 60 degrees. So 60 degrees is what? It's our reference angle. Great. So now we're good to go. We said that there's 2 quadrants. So one possible angle, or one of the angles, is this. It's in the second quadrant. And we know the reference angle is 60 degrees. And the question is, how much is that? Okay, that's a terrible degree sign. Okay, so the way we would do that is the whole half circle is 180, but we didn't go the whole way, we did 60 less. So 180 minus 60 is 120 degrees. That's one of the answers, but there's another answer, because remember we also said that in the third quadrant, cosine's also negative. So in the third quadrant, draw it like this, we have the same, well, again, this is the standard position angle that we want to know. But what we do know is the reference angle is 60. So if this is 60, how much is this whole way around here? Well, if the halfway is 180 and we want 60 more, it'd be 180 plus 60 equals 240 degrees. So what we've just figured out is that the cosine of 120 degrees is negative 1/2, and the cosine of 240 degrees is also negative 1/2. Try it out. Take your calculator and try those two amounts, and you'll see that in both of them you get negative 1/2. Okay, last one similar to that, except you'll see that the tan value is this crazy number here. That's not in the table. We never had anything like that in the table. So you will actually have to use a calculator in this one. So find all the angles between 0 and 360 such that tan theta equals negative 0.839. So again, you have to ask yourself, in which quadrants is it that tan is negative? So back up here, tan is positive here, and all of them are positive here, so it must be these two, 2 and 4. So I will write that tan is negative in quadrants 2 and 4. Okay, the next thing we have to ask is the tan of what angle equals 0.839. Remember, we don't need to worry about the negative. The negative told us the quadrants. What we're doing now is we're figuring out the reference angle, so you just have to worry about the positive angle. Okay, now if this was in the table, we would just look up in the table, but it's not. So how are we going to do this? Well, remember, just from like grade 10, if you had something like this where you're finding the angle, this is the fit rule. Remember the fit and the hot rule? This is the fit rule. You're finding the angle, so you use inverse tan. So in order to get the angle, you're going to do inverse tan of 0.839. And if you put that in your calculator, you'll get, it is a nice whole number, or 40 degrees. So this is the reference angle. Okay, we've got two cases. One is in quadrant 2, so standard position angle in quadrant 2 with a reference angle of 40 degrees. And the question is, how much is the standard position angle? Well, that's going to be 180, take away the 40, and you get 140 degrees. So that's one solution. The other one, I'll just draw a little sketch, is quadrant 4. So we have a fourth quadrant angle, and the reference angle is again 40 degrees, and we want to know how much is this angle. And to get that, you're going to do 360 the whole way around. We didn't go the whole way around though, we did 40 less. So take away 40 and you get 320 degrees. Again, I invite you to try it. Put tan 140 in your calculator, you'll get that amount. Put tan 320 in your calculator, you'll get that amount, including the negative signs. Okay, that is it. So the big job for you today is to memorize this table, but if you use my tricks, I don't think it's really that bad, and you will need it for the next 2 years. So memorize away, everyone.
Oh, man. I spell M-A